Hi, we are the Los Angeles Waterkeeper Practicum team. The significance of our project lies in the fact that 98% of streams in Southern California's urban areas show signs of degradation to ecosystem health. Most often, water is only tested for its physical attributes, but biological indicators can play a large role in understanding the multiple sources and interactions of pollutants. Within this project, it is our hope that we can better understand water stream health and use this information to preserve the health of our ecosystems. Our main research question is, does the California Stream Condition Index, otherwise known as CSCI, a measure of the biotic integrity of communities of benthic macroinvertebrates, act as a reliable indicator of water quality across the sheds of Southern California? Throughout this project, one of our main intended goals was to determine if biological indicators can reliably capture variations in regional water quality. We hope to accomplish this by testing CSCI results and determining a final CSCI analysis and a conclusion on its validity, and then eventually moving on to provide peer-reviewed data of CSCI testing to encourage the use of biological indicators. During the span of this project, our team has faced some, although small, but noteworthy challenges. First off, there's the challenge of online communications, which is sometimes not as convenient or efficient as in person. The broadness and applicability of CSCI to water bodies also presents a challenge. And lastly, barrier with data sets. Different agencies may present data in slightly differing ways. For example, the variable nitrogen may be capitalized in some data sets while lowercase in others. Essentially, the data needs to be standardized beforehand to avoid redundancies.
Our methodology has changed since the spring. We now use only chemical analysis, when before we would use sample years and watershed data. With this data, we built and evaluated an initial set of 1,000 random forest models of CSCI scores as a function of various factors. We used this random selection of 180 samples from our study area. Then we took the top 9 most important variables and selected them to create a set of 1,000 forest models along with their 1,000 individual partial response curves. The study area that we were working within was in Region 4's boundary. One thing to know about CSCI is that the closer the score is to 0, the more likely that the water body is to be impaired. However, when the score is greater than or equal to 1, it indicates that the study is equivalent to our healthy reference site, which is shown by the yellow dots in this map.
Recent findings. So CSCI is reliable with the reliability capturing 80% of all variation in water quality across the region. Our samples were taken over a 20-year span with a total of 685 samples. Of these 685 samples, 180 random samples were used to create an initial set of 1,000 forest models. On the right are partial response curves of CSCI scores and its correlation to a specific pollutant. Then you go to the next. We found the mean correlation between our initial set of modeled and actual CSCI scores to be highly correlated, as shown by the correlation coefficient of R equals 0.73 and a standard deviation of 0.16. However, most of the variables in our initial models are of low relative importance, and the performance of our models changed slightly when based solely on the 9 most important variables, in which the correlation coefficient became 0.74 with a standard deviation of 0.16 once again. Phosphorus is different because most of the samples had low phosphorus concentrations. Therefore, most of the data is concentrated on the left side of the graph, so it's more difficult to accurately fit a trend to this data. In the meantime, our team hopes to educate and increase awareness by sharing our results and having the draft of our fresh water manuscript ready for review. We will continue this dialogue in consumable ways for the public by sharing information through our website. Additionally, we have been and will continue to communicate with the Los Angeles Waterkeeper team to discuss what steps we will be taking moving forward and what steps they can take to implement these practices involving biological indicators.
Thank you.